Hey everyone, welcome to this lecture. In this session, we are going to discuss regarding the concept of Palo Alto Firewall high availability, or commonly called as HA. So HA, as it says, it's high availability, so it means that it is a concept for fault tolerance, or a concept of failover. So the purpose of high availability will be to ensure any business continuity, and it should minimize any downtime by deploying at least two firewalls in a HA pair, or in a high availability pair. That means if one firewall fails, the other firewalls will take over with minimal or very less service interruption, right? So that means I have got two HA pair over here in my DC subnet, so I want to make them into the HA pair. If one of the firewall is considered as active, one of the firewall can be considered as passive. So whichever firewall is active, it will actually take the role of the traffic flow through it, and whichever the firewall is passive will wait for the active firewall to fail, right, and transition itself to active during failover. And there is another deployment method which is active. So both the firewall can be placed in active mode, and both of them can do the load sharing or load distribution of this particular traffic from inside to outside, or vice versa, at same point of time. All right, so we have active passive deployment, active deployment, and HA is more of make sure that you have got multiple firewalls in a pair, which connects this inside to outside zone through this particular pair. And if one of the firewall fails, generally the other firewall is there for the traffic flow to occur and the firewall business process to occur. All right, so with that in mind, let's discuss regarding the HA, the very important key points, and next we'll be going through the HA configuration, right? So let's go ahead and talk about the HA key points over here. So if you look into that, I have some key points which I have tailor-made for you to start with. So HA stands for high availability, so at least two firewalls up to 16 firewalls can be called in a single HA cluster. There are multiple failover conditions that can happen, right? So the peers in the HA cluster can be in a pair or can be a standalone firewalls as well. So the HA will allow you to minimize downtime, and it will make sure that an alternate firewall is always available in the event that a peer firewall fails. Okay, now you can see that the firewalls in an HA pair. So if I go back to my topology, so the firewalls that is available, let us say this will be an HA pair in our implementation, right? So the firewall, if it is in the HA pair, it can go ahead and go ahead and sync some information, right? So it can use the dedicated or in-band HA ports on the firewall to synchronize data, right? So basically it can synchronize network, it can synchronize the network configuration, the object configuration, and in a sort of policy like net policy or security policy configuration to maintain the state information. So think this is the active firewall, this is the passive firewall. So in that case, the active firewall will sync all those network, the object, the policies configuration to the passive. So during the failover, if the active firewall fails, the passive will always know the existing state condition of the active firewall, and it can take over during the failover situations, right? So yeah, the firewalls in HA pair or cluster, as I've told you, will maintain the state information, and the firewall specific configuration, such as let us say the management IP configuration, okay, or any sort of administrative profile configuration, or any HA specific configuration, any sort of independent log data, or ACC like application command center information. So those things will not be shared between the peers, right? So I can actually write down those points over here just to make it a better. So basically the firewalls in HA pair, or you can say cluster, use dedicated or in-band HA ports. That depends upon the firewall model. So certain firewall models will have a dedicated HA interfaces inbuilt into the hardware appliance. Certain lower end models will not have that dedicated HA port. So in that case, you can use the in-band ports that is available and turn them into an HA interface. And you will see that in the configuration that we'll be doing next. So it can use dedicated or in-band HA ports on the firewall to synchronize data. So in that data, basically you synchronize the network configurations, the object configurations, the policy configurations, right? And also the state informations, right? So any configuration which is like firewall specific configs, configuration, which is like management interface IP, or any sort of administrative profiles, or HA specific configuration, or you can think about the local log data, okay, and the application command center information, right, are not shared between the peers. Good. So these are not going to happen. So what are the different conditions based on which this failover will trigger, right? So this is the different reasons. So one or more of the monitored interface fails, right? So you may have you may tell that, hey, Mr. PFW1, you are going to be my active firewall, and I want to make sure that this uplink, which is Ethernet 1/2, is going to be a monitored port, right? If this particular interface fails due to whatever software or whatever hardware or config reasons, then that failover event will trigger, and this passive firewall will be notified, right? And this passive firewall will transit itself to the active firewall state, right? So basically you can have the interface monitoring capability enabled. Okay, so this is one of the reason. So one or more of the monitor interface fails, that can trigger failover. One or more of the destination specified on the firewall cannot be reached. So might be in your primary firewall. Let us say if you have defined that, okay, if I'm unable to reach internet through my primary firewall, let us say in that case I will consider it as a failover, and I will trigger the passive firewall, for example, to transition itself to the active state, right? If I'm unable to reach any destination on the world of internet from the active one. All right, so this is one of the reason that can happen. Third point is the firewall does not respond to any heartbeat pulse. So basically the firewalls in a pair will actually have heartbeat messages, that is kind of an ICMP pings which goes between them, and if any of the firewall is unable to respond to the heartbeat pulse, so that can trigger the failover. Might be a critical component fails, right? So inside the firewall, let us say a critical chip, or might be some software component fails. It is also known as a packet path health monitoring. If that happens, then that can also trigger failover, and the other peer will transition itself to the active state. So Palo Alto Network Firewall supports stateful based active or active passive deployment. So most of the time you'll find it as active passive deployment in your environment, but very specific cases, like very specific 5 or 6% cases where you'll find active deployment. So active passive or active active both have got stateful nature of synchronization with session and config sync, which happens with few exceptions. So the exceptions are, if you go with the VM series firewalls on Azure and VM series firewalls on AWS, it support only, I should write AWS in uppercase, sorry for that. AWS, it support only active passive HA mode. Okay. On AWS, when you deploy the firewall, you can deploy the firewall with Amazon ELB service. It does not support HA. Okay. The VM series firewall on Google Cloud Platform, that is GCP, does not support HA. Okay, so these are certain exceptions that we have over here. All right, so yeah, I believe it's clearly understandable. So now the point is, in active passive what happens, and in active active what happens, right? So you've got, you know, two modes of deployment over here, right? As I've told you, one is active passive and one is active active. So in active passive, as you understand, so one firewall will actively manage the traffic while the other is synchronized, and it will be ready to transition to the active state when a failure occur, right? So as you can see here, right? So if you want to make sure that this particular pair remains in active passive environment, so this is active, this is passive, so ensure that, you know, this particular firewall will be responsible for handling all types of inbound and outbound traffic, and the passive will be just listening for the active to fail, right? And once the passive gets notified for the failover, the passive will transition itself to the active firewall role. So the idea is, in this particular mode of active passive, both firewalls will share the same configuration settings, okay, and one actively manages the traffic path until a path or a link or a system or a network failure occurs. So there are multiple events or event or failover trigger conditions, as I've told you, right? So when the active firewall fails, the passive firewalls will transition to the active state, and it will take over seamlessly, and it will enforce that the same policies are there to maintain the network security. Active passive HA is supported in different types of deployment mode, like think about virtual wire, like vWire, or layer 2 or layer 3 deployments. Okay, so as I can say here, so it supports vWire deployment, layer 2 deployment, and layer 3 deployment. In case of active active, right, it's very clearly understandable that both the firewalls will remain in the active active condition. So both the firewalls in the pair will be active, and it will process the traffic, and it will work synchronously to handle the session setup and also the session ownership. So individual firewall will have their own session setup and own individual session ownership. Both the firewalls will individually maintain, right? So both of them will be in the active active state. So both of the firewalls will individually maintain their own session table. So both of them will have their own session table and own routing table. So they will have their own session as well as the own routing table, and it will go ahead and it will synchronize to each other. And active active HA is supported in two modes. So it supports in virtual wire and in layer 3 deployments. It does not support layer 2 deployment. So if you look into that, it supports vWire and layer 3 deployments, but it does not support layer 2 deployment. Also, one thing that in active HA mode, the firewall does not support DHCP client. Okay, so remember that does not support DHCP client. You cannot configure the firewall to work like a DHCP client. Also, it will I mean, in case of active mode, what happens is, furthermore, you have kind of a roles given. So you have got active primary and you have got an active secondary, right? So let us say this firewall, the first firewall that you have over here, this is my active primary firewall, right? And this is my active secondary firewall for a particular session, right? For a particular session, right? So in that case, you have this active primary, active secondary roles also defined over here. So only the active primary firewall can function as DHCP relay. So if you want to configure DHCP relay, then only the active primary firewall for that particular session can configure or can support for DHCP relay, right? Also, one more important thing is that an active configuration does not load balance your traffic. So if you have an active setup, so it does not do the job of load balancing, although you can do load share by sending traffic to peer, right? So you can do load share by sending traffic, so certain load can be sent to the peer, and from there the traffic can be sent across to the destination. So the idea is, there is no concept of load balancing that occurs, but load sharing is possible between the peers. So there are ways to load share sessions to both the firewalls, which includes, ECMP, or might be multiple ISP, or you might use some third-party load balancers as well to do this, load sharing. So whether you decide to use active passive or active mode, you can consider certain differences. So active passive mode has got a very simplicity of design, right, as you can understand. So it has got a significant easier process to troubleshoot, and it has got an easier process to troubleshoot for routing, troubleshooting for traffic flow issues in active passive mode. As I've told you, active passive mode also supports your, if it is a layer 2 deployment, so it supports layer 2 deployment, and whereas active does not support for layer 2 deployment. Your active mode needs very careful design. So active mode requires advanced design concept that can result in more complex networks. Depending on how you implement active HA, it might require additional configurations such as activating some networking protocols on both the firewalls, might be replicating some NAT configuration between the firewalls or NAT pools, or might be deploying floating IP addresses to provide the proper failover. So because both firewalls are actively processing the traffic, the firewalls can use additional concept of session owner and session setup to perform your layer 7 content inspection. Okay, so there are two terms you'll find in active called as session ownership and session setup to perform, and these are individual roles of both the firewall, and they will actually do layer 7 content inspection. Active mode is recommended if each firewall needs its own routing instance, and you need a full real-time redundancy out of both the firewalls all the time. And active mode has got faster failover, and it can handle peak traffic flows better than the active passive mode, because both firewalls are actively processing your traffic. Okay. Okay, so let's discuss regarding this particular links that we have between this HA pairs. So you can see in my topology I have used certain links. Ethernet 1/3 is connected end-to-end between PFW1 and FW2, likewise Ethernet 1/4, and Ethernet 1/6 and a 1/7. So I'm using Ethernet 3, 4, 6 and 7 as your high availability, or called as the HA links between the firewalls. And there are multiple types of HA links. So you have got HA1 link and HA2 link, okay, and also in active deployment you have got HA3 link. So HA1 link, generally it's an layer 3 link, okay, and you can also have a backup to HA1 link. So I've got 4 links over here. So one is HA1 link and the other is the HA1 backup link. Likewise, the other third link is HA2 link, and the fourth one is your HA2 backup link. So both your HA2 link and HA2 backup link are layer 2 mostly, but if you want you can also turn them to layer 3. Now what are the purposes? You can see here. So HA1 link, it is used for control plane communication, and HA2 link, it is used for your data plane or the user traffic communication, right? So HA1 will have an HA1 backup link for its failover condition for the control plane. Likewise, for HA2 will also have its own backup link for its failover link, right? You can and you also can see that HA1 link is part of one IP subnet. So 111.201 is on FW1 and 111.203 is on this FW2. Likewise, the HA1 backup link is on 11.0 subnet. So 11.112.0.1 on one side and 11.112.0.3 on the other side. Okay, we'll do this configuration in the implementation video next. Alright, but know that these HA links that we have between the HA pairs, so they are of two types, HA1, HA2, and in active passive deployment you have HA1, HA2. In active deployment you have got HA1, HA2, and also you can have HA3 link over here.